Hello friends, I am Dr. Siraj Faisi. I welcome you in my YouTube channel. Today in this video, we are going to learn light and quantized energy. So objectives like compare the wave and particle nature of light, define a quantum of energy and explain how it is related to an energy change of a matter, contrast continuous electromagnetic spectra and atomic emission spectra. Review vocabulary means radiation. What is radiation? The rays and particles, alpha particles, beta particles and gamma rays that are emitted by radioactive materials. So my friends, electromagnetic radiation, quantum, wavelength, Planck constant, frequency, photoelectric effect, amplitude, photons, electromagnetic spectrum, atomic emission spectrum. So light, a form of electronic radiations, has a characteristic of both wave and particle. Recall that in Rutherford model, the atom's mass is concentrated in the nucleus and electrons move around it. The model doesn't explain how the electrons were arranged around the nucleus. The model does not explain why negatively charged electrons aren't pulled into the positively charged nucleus. So in the early 19th, scientists observed certain elements emitted visible light when heated in a flame. So analysis of the emitted light revealed that an element's chemical behavior is related to the arrangement of the electrons in and its atom. So visible light is a type of electromagnetic radiation, a form of energy that exhibits wave-like behavior as it travels through the space. All waves can be described by several characteristics. So, like the wavelength is the shortest distance between equivalent points on a continuous wave. The frequency is the number of waves that pass a given point per second. The amplitude is the wave height from the origin to a crest. So, you can see the wavelength, you see the crest, amplitudes. So, speed of light, is the product of its wavelength and frequency. So C is equal to lambda nu. Longer wavelength and shorter wavelength, you can see higher frequency and lower frequency. So sunlight contains continuous range of wavelength and frequency. A prism separates sunlight into a continuous spectrum of color. The electromagnetic spectrum includes all forms of electromagnetic radiation. So you can see the wave nature of light, electromagnetic radiations, EMR. The wave models of light cannot explain all light characteristics. Friends, matter can gain or lose energy only in a small specific amount called quantum. A quantum is the minimum amount of energy that can be gained or lost by an atom. The Planck constant has a value 6.626 into 10 to the power 34 joule per second. So, photoelectric effect is when electrons are emitted from a metal's surface when light of a certain frequency shine on it. You can see the electron eject from surface incident beam of light. This is the metal surface. You can see the electrons. Albert Einstein proposed in 1905 that light has a dual nature. The beam of light has wave-like and particle-like properties. A photon is a particular electromagnetic radiation with no mass that carries a quantum of energy. So, energy of photon is equal to h nu. Represent energy, h is Planck constant, nu frequency. So, light in a neon sign is produced when electricity is passed through a tube filled with neon gas and excite the neon atom. The excited atom emit light to release energy. So you can see in this picture. So atomic emission spectra, friends. Atomic emission spectra of an element is the set of frequencies of electromagnetic wave emitted by the atom of elements. You can see in this picture. So what is the smallest amount of energy that can be gained or lost by an atom? So answer should be quantum. What is the particle of electromagnetic radiation with no mass called photons? So friends, now quantum theory and atoms. These are the objectives: compare, explain identity and review vocabulary like atom. So Ground state, what is the meaning of quantum mechanical mode of an atom, quantum number, de Broglie equations, atomic orbitals, Heisenberg uncertainty principle, principal quantum number, principal energy level, energy sublevel. So friends, we call it the Bohr's model effect. Bohr correctly predict the frequency lines in hydrogen atomic emission spectrum. The lowest allowable energy state of an atom is called its ground state. When an atom gains energy, it is an excited state. So Bohr suggests that an electrons move around the nucleus only in certain allowed circular orbit. You can see in this picture. So each orbit has a given number called the quantum number. So first n is equal to 1, second n is equal to 2, third n is equal to 4, and so on. Their orbit radius 0.05 to 9 and like that. So hydrogen single electron is in the n is equal to 1 orbit in the ground state. When energy is added, the electrons move to n is equal to 2 orbits. So Bohr model of atom, you can see Lyman series, infrared, Paschen series, visible length, Palmer series. So Bohr model of an atom, this is the Bohr model energy diagram. Bohr model explained the hydrogen's spectral line but failed to explain any other element's line. The behavior of electron is still not fully understood, but it is known they do not move around the nucleus in circular orbits. So de Broglie hypothesized that particles including electrons could also have wave-like behavior. So figure illustrates the electrons orbit the nucleus only in whole number wavelength. You can see the n1 is equal to 1, n is equal to 2, n is equal to 3, like that. And he gave the one formula lambda is equal to h by mv, where lambda represents wavelength, h is Planck constant, m represents mass of particles, v represents velocity. So Heisenberg showed it is impossible to take any measurement of an object without disturbing it. The Heisenberg uncertainty principle states that it is fundamentally impossible to know precisely both the velocity and the position of particle at the same time. The only quantity that can be known is the probability for an electron to occupy a certain regions around the nucleus. So quantum molecular mechanical model of an atom, you can see before collisions and after collisions. So Schrödinger treated electrons as a wave in a model called the quantum mechanical model of the atom. Schrödinger equation applied equally well to elements other than hydrogen. So wave functions predict a three-dimensional regions around the nucleus called the atomic orbits. You know that, you see that this is the density map. You can see the nucleus, you can see the boundary. So principal quantum number indicate the relative size and energy of atomic orbitals, and n specific the atom measure energy level called the principal energy level. So energy sublevel are contained within the principal energy level. N is equal to 1 sublevel, n is equal to 2 sublevel, n is equal to 3 sublevels, and 4 sublevels like that. So each energy sublevels relate to orbits of different shape. First orbital, 2s orbital, you can see px, py, pz, you can see dxy, dyz, dzx, ds square minus y square, and dz square. So there is a number of electrons. So which atomic suborbital have a dumbbell shape? P. Who proposed that particle could also exhibit wave-like behavior? De Broglie. So friends, electronic configuration, nuclear vocabulary, electron configuration of Bohr principle, Pauli's principle, Unanswered, valence electron, electron dot structure. So friend, the arrangement of electron in an atom is called electronic configuration. We are following the principle of Bohr principle for the electronic configuration. To feature examples. So Pauli's principle states that a maximum 2 electrons can occupy a single orbital, but only if the electrons have opposite spin. You know friend, Hund's rule is also very important. It states that single electron with the same spin must occupy each equal energy orbital before addition. Null electrons with the opposite spin can occupy the same energy level orbital. You can see in this picture. So this is the electronic configuration 1s2, 2s2, you know this. Noble gas notations uses noble gas symbols in bracket to shorten inner electronic configuration of element. You can see for sodium you write neon and 3s1 and so on. The electron configuration for chromium, copper and several other elements reflect increased stability of half-filled and full-filled set of s and d orbitals. So, what is the meaning of valence electron? Valence electrons are defined as electron in atom outermost orbital, those associated with the atom's higher principal energy level. Electron dot structure, friend, if you represent electron with dot, you can see lithium, beryllium, boron, carbon, 4 electrons like that. So in the ground state, which orbital does not atom electron occupy? The lowest available. The outermost electron of an atom are called what? Valence electron. So friends, there are many key concepts. You just remember Bohr's atomic model contributions, H by mv. The arrangement of electron in atom is called atom or electronic configurations. Electronic configuration are defined by the Auber principle, Pauli-Exclusion principle, and Hund's rule. There are many different. So, shortest distance from equivalent point on a continuous wave is the wavelength. The energy of wave increases as wavelength decreases. Atoms move in a circular orbit in which atomic models, that is the Bohr models. So, it is impossible to know precisely both the location and velocity of an electron at the same time because this is the statement of Heisenberg uncertainty. How many valence electrons does neon have? See. So, a spherical orbital belongs to which sublevel S? So, what is the maximum number of electrons in the 1s orbital can hold 2? In order to 2 electrons to occupy the same orbit, they must have opposite spin. So, how many electrons does boron contains? 3. Like that. What is quantum number? The smallest amount of energy that can be gained or lost by an atom, that is quantum. So, this is the image bank. Just remember in your mind, you see the image bank like wavelength, wave number, amplitudes, longer wavelength, shorter wavelength, EMR, electromagnetic radiations. This is electronic effect. You can see this is a line spectrum, ground state and excited state, energy level, Bohr's models, and different you can see. So friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.